Time to talk about enthalpies of formation. I guess I shouldn't try and say that word so fast. Chapter 5, Section 7. Formation, meaning something is formed. We're going to create something, and we need to know how much heat is either released or gained when we create that. Okay? And there are lots and lots of tables about this. People have done all kinds of chemistry experiments. There are tables for vaporization, tables for fusion, tables for combustion. I'm not going to show them to you because you don't want to see them. If you really want to see them, then you can go online and look for them, or you can look in your book. Okay, and then here's what the enthalpy of formation actually is, and it uses that big word constituent elements, which just means the elements that it's made of, okay? So it's the thermochemical data for making a compound out of its parts, okay? Constituent parts. All right, and here is the symbol for the enthalpy of formation. Notice the F, that's for formation. That little symbol is going to change as we go throughout this little talk, okay? So, moving on. Remember that enthalpy is a state function, okay? So, it is dependent upon temperature, pressure, and state. And most reactions would be performed with the substances in their standard state. What's their standard state? That means, you know, what you find them at every day. What they are labeled as on the periodic table when you have a periodic table that's in color and they put some things in blue because they're liquids and some things in red because they're gases and, you know, whatever color they choose to use, bright pink. Okay? The standard enthalpy change is the enthalpy change when all reactants and products are in their standard states. And notice now that there's nothing down here. This is the standard enthalpy change, okay? And now for the standard enthalpy of formation. We are, let's see, the change in enthalpy for the reaction that forms 1 mole of a compound from its elements with all of the substances in their standard states. That is a mouthful. What does it all mean? Just what we just said earlier at the beginning. When we talk about a formation, we're saying that something is formed, and what is it formed from? It's formed from elements, okay, in their standard states, all right? Okay, so we have a little, I don't know, kind of reaction here. You get your elements in your standard states, and those turn into a compound in its standard state. All right. So here's our first example. It is the example of ethanol, which is C2H5OH, and we need to figure out what that is made of. Well, it's made of carbon, hydrogen, and oxygen. Okay, and here's another hydrogen right here, but that's still hydrogen. The most stable forms of these elements is used, and we only make 1 mole. So what's the most stable form of carbon? Well, you can get carbon in graphite form. There's solid carbon, right? There's solid graphite or there's solid diamonds. As much as I would like diamonds to be the ones that are, you know, the most abundant, they're not. So that means that we're going to use carbon that looks just like this in its solid form, okay? What is our form of hydrogen that we see most often and is most common and is in its standard state? That would be H2, right? And then oxygen, oh, and that's a gas. Oxygen also comes in twos and as a gas, and that would be O2. And together, this is